Okay guys, today we're gonna go over how to program a GM9S furnace. Very common. You have to program the board to make it work properly. So you have the LED display right here, and you have the push buttons here, option and menu. So basically, when you come over here, the first thing that you're gonna need to do is go to the ODS, because the default setting is off. You have to tell it has an AC. If you don't, it's gonna run very low fan speed. Then the next thing that we're gonna do is basically we're gonna program the fan speed for AC. You have 9 different speeds to select from. We'll go over the blower chart in a sec. And we need to select also the gas heat fan speed, which is GAF. And you have on this one, I checked already, you have 5 different speeds. Okay, so we're gonna go to ODS, which is outdoor unit size, and we have AC1, heat pump, AC2, heat pump 2 stage, off, which is the default. So we're gonna go back in and select AC1. Selected AC1, press menu. Then we're gonna keep scrolling down. So now we're gonna go to AC1 and select fan speed. So we're gonna press again here. And I already selected tap 8, which we're gonna check in the blower chart right now what is tap 8. And then we're gonna scroll to GAF or GAF. Oh, I just passed it. GAF, and I set it to the highest speed. You have only F1, F2, 3, 4, and 5. So we're set to tap 5 and tap 8. Okay, so the unit we have is the GM9S 60,000 BTU 4-ton. And then the factory speed for AC1, because this is the cooling chart, is F06. And for AC2, if it was a 2-stage, it will be 08. Now, since we did the airflow class, we know that most of these units gonna run around 0.6 to 0.8. So if we're gonna put it on 0.6, it should be around 3.5 ton capacity. If we're gonna put it on 0.8, it's gonna be 3 ton capacity. So we're gonna check the static pressure right now. On high speed, I'm gonna select tap 9, and then according to that, it will determine which tap I'm going to select. Now on the second page, it's the heating chart. So you're gonna go 4-ton 60, factory default is F04. You're gonna go F04, and you're gonna go all the way to the side, and it's gonna show you the airflow, and it's gonna show you the temperature rise. You have the temp rise on different units here. Basically the temperature difference between the supply and the return, what it needs to be so it doesn't overheat. Okay, next thing is zeroing out our manometer. 0, and always the pitot tube needs to sit against the airflow, so the airflow hits the tip of it. That's how it measures our static. So then I remove the high limit switch. Arrow is facing over there. Make sure the high limit is not touching any pieces of metal so it doesn't pop our fuse. Then we're gonna go to the return one as well. I drill the hole that I'm gonna cover later, and we're gonna make sure that we're in the airflow. And let's go turn our unit on. Okay, so we're set to cooling, and our total pressure right now is 0.85, 0.8. So we're gonna go to 0.8 because that's what I set the cooling airflow to, and we're running approximately 1540 CFM, but we're a little bit over the 0.8, so it's gonna be probably around 1500. So we know 1500 is a little bit too much for a 3.5 ton. So what I'm gonna do is I'm gonna lower it to tap 7, which should be the exact one that we need. We're gonna test it again. I selected the tap 7, and as we can see, our static is a little bit lower. It's 0.7, 0.8. So we're gonna go 0.7, 0.8 on F07, and it gives us around 1400 CFM, which is a 3.5 ton, which that's the units that we installed over here. So we know already it's the correct amount of airflow for this unit. And I spoke to the installer. We weighed in the charge according to the line set length minus the factory charge. So when I come back in the summer, I know I have very, very minor adjustments, maybe a couple ounces of refrigerant just to top it off to the correct amount of subcooling on this specific unit. Now, after we finished with the cooling, we're gonna check the heating. Okay, so now we're gonna test the heater. So I disconnected my probes, zeroed out the manometer. Now basically we're gonna connect our probes to the inlet and outlet of the gas pressure. And then before I do that, I just wanted to show you. So basically what we're looking for is incoming pressure to the valve needs to be minimum 5, and our output from the gas valve to our burner needs to be 3. Okay, so we're running 10 minutes. As you can see, incoming pressure is 5 inches of water column. The pressure after the valve, after I adjusted it, it's 2.95 inches of water column. Then we're running on tap 5, and our heat rise right now, I'm just looking at my Job Link Pro. My iPad just turned off, but I'll send you a screenshot. That's 30-degree heat rise. So we're right within the range of 20 to 50 degree difference between the supply and the return. So commissioning is done. Just need to come in the summer to check the refrigerant charge, and that's it for today.